There's a substance sitting in your kitchen right now that has been generating warmth for over a century, not as a curiosity, not as a chemistry experiment, as a documented, field-tested, industrially verified heat source that military engineers relied on before the first roads were paved in rural America. It requires no fuel line, no electrical outlet, no monthly invoice. And the reason you have never been shown how it works is not because it stopped working. It is because it never stopped working well enough to need replacing. The year is 1912. Inside a metallurgical research facility in Dusseldorf, Germany, industrial chemists are documenting something that would later vanish from every consumer-facing publication in the Western world. They are recording the precise thermal output of accelerated iron oxidation in a saline electrolyte environment. In plain language, they are watching iron, water, and dissolved mineral salt release sustained, concentrated, measurable heat. Not a flicker, not a momentary warmth. Hours of stable elevated temperature from materials that cost fractions of a cent per gram. The documentation was published, the reaction was understood, and then, over the following 4 decades, the knowledge was not banned, not classified, not destroyed. It was simply never handed to the public in usable form again. That gap between what chemists knew and what reached your household did not happen by accident. Before the Second World War, most American families heated their homes through decentralized means. Wood, coal, and kerosene were purchased in loads, stored on site, and controlled entirely by the household. No single company owned the pipe bringing warmth into your living room. Then the post-war infrastructure expansion changed everything. Between 1945 and 1965, natural gas distribution networks were built across the continental United States at a pace that had no precedent in American infrastructure history. Furnace manufacturers scaled production, and a new economic model for warmth was established, one requiring your permanent, recurring participation. The global heating equipment market today is valued at over $128 billion annually. That number exists because warmth was converted from a resource you could produce into a service you could only purchase. What makes this chemistry threatening to that business model is not complexity, it is simplicity. Iron is one of the most abundant and reactive metals on the planet. The moment unpassivated iron is exposed to water and oxygen simultaneously, an exothermic oxidation reaction begins. Exothermic means heat releasing. The reaction generates approximately 826 kilojoules of thermal energy per mole of iron fully oxidized. It is the thermodynamic reason commercial hand warmers routinely sustain surface temperatures between 54 and 66 degrees Celsius for 8 to 12 continuous hours from a sealed pouch no larger than a playing card. The mechanism behind the acceleration is worth understanding because it is the difference between iron slowly rusting over weeks and generating usable heat in under 10 minutes. Iron naturally forms a thin, passive oxide layer on its exposed surface, a microscopic shield that slows further oxidation almost to a standstill. What dissolves that shield is the chloride ion, released when sodium chloride, ordinary table salt, dissolves in water. Chloride ions attack the passive oxide layer through a process called pitting corrosion, penetrating the surface chemistry and exposing raw reactive iron to the electrolyte. Once that barrier is removed, oxidation proceeds at a rate that is not gradual. It is rapid, measurable, and heat-releasing. The same electrochemical mechanism that destroys car frames in northern climates where road salt is spread every winter is the mechanism generating warmth inside every commercial hand, warmer sold in this country. The chemistry is identical, only the application differs. Here is where aluminum foil enters the picture, and this is the detail that elevates a simple reaction into a functional heating tool. Polished aluminum has an emissivity rating of approximately 0.03. Emissivity measures how efficiently a surface radiates thermal energy away from itself. That rating means aluminum reflects roughly 97% of the infrared heat contacting it, rather than releasing it. This is the same principle behind emergency thermal blankets in search and rescue operations, and behind aluminum-faced insulation in residential attic spaces. When an active iron oxidation pack is wrapped in aluminum foil with the seams left slightly open, radiated heat that would otherwise dissipate is reflected back inward, concentrating the output against whatever surface the pack contacts. The small gaps at the crimped seams allow just enough oxygen to reach the iron inside to sustain the reaction without accelerating it past safe control. The foil is not decoration, it is a directional thermal mirror. Here is the practical construction, and this is what the industry priced out of your reach by selling you the finished product without ever disclosing the formula. Fine-grade steel wool, labeled 00 or quadruple 0 at any hardware or paint store, contains maximum iron surface area per gram because the filaments are drawn to extreme fineness. One standard package costs approximately $2 and contains enough material for 10 to 15 individual heat packs. Dissolve 2 tablespoons of table salt into a cup of warm water. Submerge a tennis ball-sized section of steel wool in the brine for 60 seconds. The chloride ions are stripping the passive oxide layer from every iron surface in the wool. Remove and squeeze firmly. The target state is damp, not dripping. Standing water displaces the oxygen the reaction requires. Bone-dry iron loses the electrolyte mediating electron transfer. Shake the prepared steel wool briefly in open air. Within 30 seconds, you will feel warmth building in your hand. That is the reaction. Beginning. Wrap the warming steel wool in 2 complete layers of kitchen aluminum foil, crimping the edges firmly, but leaving small gaps at the seams for air exchange. Place the wrapped pack inside a fabric sleeve. Within 5 to 10 minutes, surface temperature stabilizes between 49 and 63 degrees Celsius and holds there for 6 to 12 hours depending on the mass of steel wool used. By 1988, Japanese manufacturers were producing 450 million disposable chemical heat packs annually, not as emergency products, but as everyday consumer items on the shelf of every convenience store in the country. In the United States, that same chemistry was packaged into single-use pouches, priced individually, and sold without any ingredient disclosure that might have invited the obvious question. The commercial hand warmer industry generates hundreds of millions of dollars annually by selling iron filings, salt, water, activated carbon, and vermiculite at a markup exceeding 3,000% over raw material cost. The oxidation of iron cannot be patented. It is thermodynamic law, documented in electrochemistry reference texts since 1920. What was sold to you was not the chemistry. What was sold to you was your own ignorance of it. For a family sheltering in a single room during a winter power failure, 5 medium heat packs distributed across 60 square feet of space and placed on elevated surfaces can raise the ambient temperature 10 to 15 degrees Fahrenheit above outdoor conditions through an overnight low. Total material cost for 5 packs is under $4. A 200-foot roll of aluminum foil supplies material for approximately 20 complete double-layer wraps. 40 heat packs for under $10 in total materials, each sustaining warmth for up to 12 hours. 2 safety points must not be skipped. The reaction consumes oxygen as it runs. In a sealed space with no ventilation, multiple large packs operating simultaneously will deplete available oxygen to dangerous levels. A cracked window or vent gap is sufficient air exchange. The foil surface at peak temperature can cause minor burns on direct skin contact. Handle through fabric at all times. This is the category of knowledge that Secret in Solutions was built to recover. Not because it is radical, because it is proven, practical, and owed to you. The reaction was never lost. It ran in that German facility in 1912, in frozen terrain in the winter of 1950, and on convenience store shelves in Tokyo in 1988. It was simply never handed to you in a form you could use. Now it has been. What would you do with warmth that costs nothing and answers to no one? Leave your answer below. If recovering buried practical knowledge matters to you, subscribe, because what is coming next involves electricity generated from 2 common metals and damp earth, a method documented before the first commercial power grid was ever switched on.